Hello, welcome to your lesson on piecewise functions. This is something you may be familiar with. As you can see on this graph here, we have a single function, but it's kind of broken up into three parts. Each of those parts it can be described by a single function. So to show this entire function as one piece, as one whole, we write the function equals, and then we split it into its three components, describing on which domain each of those components occurs. For example, here we have a line, but that line goes from negative infinity to -2 only. So here we have the equation of that line with a negative slope, and it's on this domain, values less than -2. The middle portion is a parabola, so we have x squared, and that's on the domain from -2 to 2. And the last portion of this entire function is this horizontal line, which can be described by the equation y equals 6. And that's for x values greater than 2. So that's a piecewise function. We've looked at those before. But now we're going to look at how piecewise functions help us with bivariate data. So we've often had data like this. We have an independent variable, a dependent variable. That is now bivariate situation. We plotted the points and we're looking at doing some bivariate analysis. So we want to know what the correlation is. We can find an R value to describe the strength of that correlation. We can also graph a line of best fit, also known as a regression line, to represent that data set. And finally, we got to the obstacle of what about if we have data that could be modeled with one line, however, may be better modeled by two lines. So we have this first portion of the data set is modeled by this line, and the second portion by this line. So we've essentially said there are two lines of best fit, one on this domain and one on this domain. And we created a piecewise function for that. So we have this line represents this one here, and this equation represents this line here. And we have a domain defined here from 0 to 50 is this line, and from 50 to 100 here is this line. Okay, so to summarize piecewise linear functions, please read this slide. So pause now, read through this, and then we'll look at a couple questions together. Okay, so let's take a look here. We have this piecewise function describing this graph here, and this graph models the distance traveled by somebody on this axis against time. So it's somebody walking to a coffee shop, they're making some distance, then they arrive at the coffee shop, they sit down, so now their distance is not changing, but time is still passing. So we can see this can be modeled by a piecewise function given here. How would you use this formula to find f of 23? So what is f of 23? So first of all, that function there is right here, and this function here is this portion here. So when we're looking for f of 23, we're going to use the f of x equals 30, this second function here, because when x is 23, that is a part of this graph here. So we're going to use this green one. And when x is 23, y is always 30. No matter what happens in this part of the graph, x can be any value, but y will always be 30. So the answer to that is 30. All right, now let's find f of 10.5. All right, there's that last point. F of 23 is here. So x is 23, y is 30. Okay, for the second one, f of 10.5, we're going to use the first function, because 10.5 is within the domain of the first function. 10.5 is somewhere here. Okay, so 10.5 put into this equation gives us an answer of 20.5. And that point is right there. Great, that's the basics of these kinds of functions. Let's try some more problems. So here's another piecewise function. Find f of 0, and then find f of 6. And state the domain as well. Okay, so f of 0 is 4 because 0 falls within this domain. Therefore, we're using y equals 4 to find out this value. And again, when y equals 4, doesn't matter what x is, it will always produce a value of 4. F of 6 is within this domain, so we use this function, and we should get 1 for that. because when 6 is substituted in here, we have 7 minus 6 is 1. Finally, the domain of the entire function is the domain across both parts, across both pieces, so we have -2 through 7. And here's the graph of that. You should be able to graph piecewise functions as well. Okay, so given this piecewise function, sketch the graph. This is the graph you should have produced. As you can see, when x values are less than or equal to 2, it is this equation, which has a positive slope and a y-intercept of 1. So here's our y-intercept of 1, and a slope of 2 tells us we will go up 2 over 1, up 2 over 1, and we'll end up right here, which is the end of that domain, so we stop that line there. Since it has an equals here, we're going to do a closed circle. In the other direction, there is no domain restriction. It says x values less than or equal to 2, so we show all x values less than 2, and there's an arrow here showing goes forever. The other function is y equals 6 when x values are greater than 2. So y equals 6 is a horizontal line like this, and it is not equal to 2 here, so it is open circle. Goes on forever. Great. Now let's do the reverse. We're given this function as a graphed form, and your task is to write a piecewise function for this. So this is not perfect notation here. Imagine this curly bracket is all the way, and we're filling in the two functions and giving the domain for each one. Okay, hopefully for that one you came up with this. The equation of this line is x plus 2, and that occurs when x values are less than or equal to 1. Closed circle at less than 1. Alright, this equation for this line is negative x plus 4 or 4 minus x. Make sure you can recognize this as a linear equation with a y-intercept of 4 and a slope of -1. So if you follow this, it will intercept at 4, and the slope is -1, so down 1 over 1, down 1 over 1, and so on. Okay, there you go. Hopefully you came up with that. On this one here, please read out this situation to yourself and see if you can draw a graph that models this situation. Hopefully for this one you came up with something like this. Very slight change in slope here, but it's definitely two linear pieces. Alright, find the practice assignment related to this on the lesson calendar. This practice assignment should feel not too difficult. So once you're done that, please proceed to the unit review, which is going to review all concepts from this unit. You can do it.